Well, Joel, it's just you and me on New Year's. So we're recording this just before New Year's Eve. Rosemary is off on holiday and enjoying the Australian summertime. Meanwhile, Joel and I are back in front of the hot cameras and microphones recording you a new Uptime episode. And we have a lot on the docket this week. Japan is starting some commercial offshore operations in the Akita prefecture. It's sort of northwest Japan, where there's a ton of major big lightning strikes in the wintertime. So I'll keep my eye on that one. And then IntoMachines is introduced an automated bolt tightener that just runs around and tightens bolts on towers so that you kind of keep technicians' time better spent somewhere else.
We'll talk about GustoMSC plus NOV plus Liftra. And their new offshore blade installation tech. It's kind of like we'll talk about some throwbacks to my younger years of shingle ladders moving blades up a tower to install them offshore. So we think it could be huge for the Jones Act here in the U.S. And then we're going to talk about in German waters some acoustic pingers that they have installed on the foundations of all their offshore wind turbines to make sure that submarines aren't running into them. So maybe the Germans are operating a little bit differently than the rest of the world. And then we'll touch real quickly on Aerones and as well their big $39 million haul that they've made to expand the company and scale it up and grow. So congrats to those guys.
And then I have an interview with Henrik Stamer from Naver Energy on the offshore wind supply chain challenges and the effects on operators. And that's a really good interview, so stick around for that. I'm Alan Hall, president of WeatherGuard Lightning Tech, and I'm here with my good friend from Wind Power Lab, Joel Saxton. Rosemary is on holiday, and this is the Uptime Wind Energy Podcast. Well, Joe, Marubeni has started commercial operations at its Noshiro port offshore wind farm in Japan. And actually, there's Marubeni has two projects going, one in Noshiro and another one in the Akita port. And so this is really the first sort of commercial scale offshore wind project that's happening in Japan. And it's on the northwest corner of Japan on the sort of the main island there, which was where there's a lot of wind turbines just onshore of that. So just onshore, there's miles of wind turbines. And it happens to be probably the one of the strongest lightning strike zones in the world.
No good.
Yeah. 200,000 amp lightning strikes are pretty common. 300,000 amps has happened there. And there has been a 400,000 amp strike. I don't know if it's in that neighborhood, but it was around there.
What does that do to a turbine blade? I mean, does it just literally blow it apart? Like, shred
Swiss
it?
cheese.
Like, none left?
It caused a fire too. So it's not just that there's a lot of energy; it's also really hot. So this is an interesting development, and I'm glad to see Japan is taking this on. They've learned a lot about lightning in Japan, and if you read some literature about lightning in Japan, there's been a ton of really good long-term wind turbine research with video and monitoring. Just to see what's going on there. So the Japanese have a pretty good handle on it, I bet. But they're putting Vestas turbines in, Vestas V117-4.2 MW machines, which are fixed bottom. And then they have 33 of these turbines between the two ports. And it's going to create about 10... Well, no. It's going to power about 150,000 homes. But Japan's trying to get on that kind of scale the U.S. is. They plan to install 10 gigawatts of offshore wind by 2030, and then they're hoping for 45 gigawatts by 2040, which is a pretty rapid increase. So they have to get this first farm in and get it running to see how they make the remaining farms, I'm guessing.
So correct me if I'm wrong here, but for something in the back of my head tells me that in Japan, they had a rule that at a lightning strike, you had to shut the turbine down to inspect it to make sure it was good to go every time before you put it back into commission. Is that right or wrong?
Maybe.
Okay.
Maybe. I know they have monitored a lot of wind turbines and instrumented a whole bunch of them, particularly in Akita Provencher, which is where these wind turbines will be. I don't know if they have rules about offshore like that. If they do, that's going to be a little bit of trouble.
Yeah, that's tough. So a couple things about it that I'm looking at the kind of the press release here and a couple bullet points. I really like how they're doing 10 gigawatts of offshore wind by 2030 and 45 by 2040 because it's more realistic, right? They're like, let's get everything kind of moving. Let's get some, because they're going to have the same struggle that everybody else is right now in the world trying to do offshore wind.
Yep.
There's no vessels, and the expertise is limited. Right. The expertise is not everybody knows how to do it. And I know a lot of the players that are involved in some of these, I don't know about this wind farm specifically, but I know in some of the bids and the leasing rounds in Japan, there has been some companies that have quite a bit of experience. Right. So there's some of that North Sea experience floating over there as well. So great to see that they've got some goals, 10 gigawatts. I know that Japan has some great wind resource. All around the whole island. I mean, it's kind of what happens when you're an island as well, and in some trade winds.
Yeah.
So that's great to see. So happy that they're getting this thing going. 150,000 homes. That's another thing that piques my mind there when I see 33 turbines powering 150,000 homes. As a lot of the business that I do is onshore U.S., we don't see as many of these 4.2 and higher megawatt machines. So when you start talking offshore, it's always really cool to see 10 turbines are going to power 50,000 homes. It's like, wow, that's amazing. So to see only 33 turbines can power 150,000 homes. And it's looking good. I like what they're making moves on here. And the weather is definitely something to keep an eye on. Like you were saying, Alan, strong lightning over there. So
and it snows there a good bit, right? So the lightning strikes in that part of the world happen during the wintertime. So this just coming up in January, early February will be peak lightning season through about May, late April, May. We're going to be peak lightning season for that region. So we have to just watch the news. There will be news about it if one of those turbines gets struck, I'm sure, because they're brand new. And at least the Japanese companies I've worked with have done a tremendous job of maintaining the wind turbines. It's crazy how well those wind turbines are operated, unlike some of the American ones, which seems like at times the blades are barely hanging on. In Japan, it's like, wow, it's like a pristine new machine all the time.
It is amazing to watch.
Yeah, I know. Right. That's my thought too. It's like what's the Department of Energy doing when we have countries that have really structured ways of going through new technology? Are we sending people over there to watch? To check out how this is going down, and are we trying to bring some of that knowledge home? I hope so.
Yeah, I know that it's not real easy to get data out of Japan. I'm thinking in the back of my mind, man, I wonder what kind of uptime percentages they have as compared to what our O&M activities look like here. I'm thinking, I wonder if Phil's got some information on this from Intel Store there about
maybe
about what's going on in Japan. But I also, from some business dealings in the past, it's not easy to get information out of Japan either. So we'll see.
Well, let's ask Phil. Let's ask Phil to follow up with it and just to watch how this offshore wind farm develops. Give it 12 months, and then we'll have a pretty good read on it. But my gut tells me this is going to be amazingly smooth because they have been in that area with wind turbines for quite a number of years. So the only new part of this is the offshore bit. The rest of it, I think they got figured out.
Looking at the image here too, of this wind farm, it's actually more, I would call it near shore. I mean, these things are, you could
throw a rock out there.
Yeah, you could do drone inspections on these turbines from shore. You don't need a vessel.
Genius. Yeah, you could.
You could just they're the furthest one out might be a kilometer, but it doesn't even look like that. You could easily get out there on one battery, do an inspection, and come back with one of these autonomous drones. So
smart planning.
Part of their O&M strategy.
That's part of it. Yeah. Well, the latest I've seen on LinkedIn, Joel, about bolt tightening which is a big area, because think about the millions of bolts we're going to install on wind turbines over the next year or two. It's got to be a couple of million. If you think about all the wrenching and tightening and verification that happens, you can eat up a lot of technician time by doing that. And when I stumbled across this LinkedIn post from IntoMachines, they were showing an automated bolt tightener, and it's like 2 bolt tightening tools, guns, I'll call them, that are on a trolley. So as you tighten the bolts around the tower, it follows that rail, and so it just drives down 2 nuts, lifts itself up, scoots over, drops 2 more, tightens 2 more, and it showed a technician with a wristband with like a gigantic iWatch. That's what it kind of would look like. And he's pushing buttons. Now, I have no idea if it made, played music. I don't know what that little wristwatch was doing, but the implication was the technician was sitting there pushing this watch device to make this robot tighten bolts. Now, I haven't seen anything like that. Everything I've seen from bolt tightening has been these guns that are, it takes a human to squeeze a trigger and move it over, sort of thing. This looks like something that makes sense from a sort of mass production way of doing it. And my first thought is, don't they do something very similar to this in the automotive world?
It's not that hard it doesn't take that, I guess, in my mind, it doesn't take that much ingenuity to create something that goes, stop at 100 foot-pounds of torque, and then, I don't know, print me out a receipt that says this bolt is at 100 foot-pounds of torque, so that I can show my supervisor, or when someone comes back on me and says, hey, were these bolts all tensioned correctly? Yes, they were. They were on this date, and here's the receipt. Or a digital signature or some sort. And I know there's a couple of other companies out here doing stuff like this, and up the top of my head, the names don't come to me. One of them is TorqueCom, I think.
I haven't crossed that.
But it's a tool, same concept. So everybody can see that we have within the wind industry space, whether it is technical field advisors, commissioners, construction personnel, O&M personnel, up to anything up tower, we have a shortage of skilled and trained technicians, and there's a ton of new people coming into the industry. And so we applaud that there's a lot of people rolling over into it. You're going to see some automotive people, you're going to see some other, mechanical types coming into this thing. But so we need as many people as we can, and it's scaling so fast. As we've talked about a few times, another 100,000, 120,000 turbines in the next 10 years in the U.S. We're at 70 right now, and we're having problems staffing these ISPs and these other companies that are making this energy transition happen for our country. It helps us to be able to scale our workforce without having to put in hours and hours of training and this and that. And so now you've got everything is reportable. I mean, I think I've seen, and I can't remember if it's TorqueCom system or not, but like every bolt head, there's a system out there every bolt head has a QR code. And the actual torque gun reads the QR code, and then it goes into a database that's like, here, on this date, that was tightened to this much based on that QR code.
Oh, wow. Is that EchoBolt you're thinking about? Is it EchoBolt in the UK? I know they do something similar where they're checking the bolt tension via ultrasound means.
I don't think it's them. I think this was actually a gun, like a torque gun. So like everybody talks like, oh, did you 10% these? Did you 10% these? Like, so those are like all maintenance things that need to be done. So I could give you some like firsthand experience. Now, I think for the most part here, we're talking bolt tensioning for tower sections is what we're mostly talking about. Right. But there is also, anybody that knows wind turbines knows that there's a whole slew of blades or of bolts around the blade, a root section that bolt into the spinner, the hub. That's another area that we need to make sure that we get just right. So if you over tension metal to metal bolts and studs, that's a problem. You shouldn't do that. That can lead to fatigue issues down the road and blah, 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 blah. Right. But you have a little bit more of a safety factor there. When you're tensioning bolts from a composite to steel, if you over tension those, you can create problems immediately structurally for that root section and those root bolts and how everything ties together there. So having a little bit more process driven control, I don't want to say robotic control, because that's not really what I'm more looking for. A process-driven solution,
Right.
That has checks and balances within itself and gives
Checks
you a
and
report.
balances.
And I think it's an open market space that's not flooded yet. But I think that I believe that you could have insurance companies start saying you must have one of these, or
I think so.
Municipalities, states, federal government saying you must be torqued. Because if you go to, I'm sure your aeronautics knowledge, Alan, that the FAA's got some. If you don't have this torqued correctly,
yeah,
you know what I mean. So
yes. Yeah.
Let's learn from other organizations and industries to make sure that we're doing the same thing. I think it could be safety for all. And
this makes complete sense to me. And IntoMachines is based in the Netherlands, according to their website. The website looks to be somewhat new, weirdly enough. So there's not a ton of information on it, but if you want to go check them out, you can go IntoMachines.com, IntoMachines.com. Take a look at these bolt tensioning devices. They have a couple, and it looked like on the website you could purchase a bolt tensioning system, but that page wasn't working when I was on it. So this whole concept must be new, but they're going to get flooded because based on the feedback on LinkedIn, there's a lot of interested parties. So they better get ready to start making some of these tensioning machines. They're going to have a busy winter.
Don't forget the Uptime podcast bump that we just gave them, increase in traffic on their website. You're welcome.
You're quite welcome. Yeah. Joel, there's a new type of blade lifting system for offshore wind turbines. GustoMSC is created basically a trolley system. So I've watched a couple videos trying to figure out what they were talking about specifically, and they have a video that shows it. So think about your standard ship jackup vessel with a bunch of blades on deck, right? And the blades are stored obviously horizontally. Mm-hmm. So these blades are all stacked up on deck. You jack the vessel up, and then there's like this trolley gantry that reaches from the ship up to basically the bottom of the nacelle. So the tower and the nacelle are already installed. All that work is done with a big, heavy jack-up vessel with a big crane on it to put all that together. Those components are heavy, but the wind blades aren't nearly as heavy as in the nacelle, obviously. Mm-hmm. So you can use basically a simpler system. So they have this trolley gantry that they attach between the ship and the tower, and then it has a little a trolley that sits on it. So it goes up and down these rails. You hook the blade, set the blade on this trolley. The trolley spins the blade so it's vertical and slides it up these rails, railroad track kind of thing, and then they bolt it into the hub. So the benefit of the system is that instead of having limitations on wind speeds from usually it's in the 12 to 13, 14 meters per second limitations on when you can hang blades, they think they can jump that up to about 18 meters a second. That's a pretty big shift. And it doesn't have a big crane. So you don't have a big, expensive, heavy lift crane involved. Right. So it's just a lot simpler to do. Right. I mean, right. So now that go ahead.
Well, you're eliminating you can go to a smaller jackup. You're eliminating the massive specialized vessel. That's the big savings here. Right. And so, so smaller crane, of course, you're not lifting the blade as far once it's grabbed basically by the Liftra is also helping these guys with all the lifting tools, right?
Okay,
so
that makes sense.
Yeah. So what I'm looking at it is okay. So when I was a young kid, to make money in rural Wisconsin, we roofed houses and stuff, right? So it looks like what we would call a shingle ladder. And a shingle ladder is...
It is. That's what I thought, too.
Yeah, like it's got the motor at the bottom, and then it's just like... and you throw bundles of shingles on it, it carries them up ladder. That's when we were really killing it. And we didn't have to back the truck up to the edge of the roof and throw them on. But that's basically what it is a shingle ladder. So the questions that it raises for me is, okay, so these blades, of course, they're not the heaviest component up there. We know that. But you're still going to be at... For one of these offshore wind turbine blades, it's a 75 to 90, 100-meter blade, you're still going to be 15 tons. I mean, they're not light.
Oh, yeah.
So you put some engineering, there's got to be some engineering done on the strain or the level of force that you're putting onto that tower as this thing is kind of leaning on it when it goes up.
Right.
So there's something there, but I do believe that's, I mean, of course, these guys have covered the NOV is involved in it as well, right? So they've done the engineering. They know what they're doing.
Yes.
But my mind keeps floating to the speed and tenacity at which the U.S. wants to install wind, and a solution like this.
Bingo.
Yes, big time. Like, you don't have to have that crane.
Speed.
You don't have to have that big crane jack-up vessel sitting at that one turbine. They work in conjunction with each other and just boom, 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 boom,
Right.
boom, down, leapfrog down the line. So there's definitely some advantages to it. How fast can they get it mobilized and out in the world working? I think it's quick. To me, it does. The engineering behind it doesn't look that difficult, to be honest with you. I mean,
No, it doesn't. Steel-wise, it's pretty simple. It's just a lattice structure that you're building.
Yeah.
That's really the complexity part of it. And the trolley, I suppose.
Yeah.
Having some way of pulling it up and down, but that's standard crane work.
Yeah.
From what I can see.
It's a scalable solution. It looks like they could build them pretty dang quickly.
Well, don't you wonder if that's part of the solution? And we're seeing so many new ideas, and because of the offshore complexity and the cost, and everybody's trying to hone in on, how many people does it take to do this? How long does it take to do it? What conditions can you install wind turbine blades in this particular case? All those factors come in to start to drive down the cost of offshore wind. And the only way you do this is because you have farms in Europe that have been operating for a couple of years.
Mm-hmm.
I think I saw a 5-year anniversary for one of them recently. That, if we had to do it all over again, what would we do? Well,
yeah,
here's a new concept.
Yeah, I mean, in this one, I'm looking at the pictures of this vessel. This is something that could be, like I said, it's not complex. This is something that could be easily Jones Act compliant very quick.
That's what I was thinking too. Yeah, it has. Though they didn't say that when I was watching the presentation from GustoMSC. It was from this previous fall. They didn't talk about Jones Act, but the whole time I'm watching it, I'm thinking Jones Act, Jones Act, Jones Act.
Because the jack-up is not anything special. That jack-up exists in Louisiana.
No.
There's 100 of them out of Port Fourchon right now. But the little bit of a crane setup, that lifting mechanism from Liftra, that's standard. That's a single point hookup. Like, that's nothing custom and new about that. Those exist. And then that lattice tower work kind of shingle ladder thing that we're talking about, that's not a big feat of engineering. That's a couple weeks in a laydown yard with some good welders and some coating specialists, right? So that I think that this is something that could be readily adaptable to be Jones Act compliant, to help our offshore wind in the U.S. scale up and get moving.
Yeah, it's a really interesting idea, and I think we may see this one coming to a shore near us in the next couple of months. We'll keep an eye on it.
Ping Monitor is a continuous blade monitoring system which allows wind farm operators to stay ahead of maintenance. Wind techs can often hear damaged blades from the ground, but they can't continuously monitor all the turbines. They also can't calculate how bad the damage is or how fast it's propagating based on sound, but Ping can. Ping's acoustic system is being used on over 600 turbines worldwide. It allows operators to discover damage before it gets expensive and prioritize maintenance needs across their fleet, and it pays for itself the first time it identifies serious damage or saves you from doing an unnecessary visual inspection. Stop flying blind out there. Get Ping's ears on your turbines. Learn more at pingmonitor.co.
Joel, we've all seen The Hunt for Red October, that great movie with Sean Connery and Alec Baldwin. And we know that submarines really operate in these quiet zones under the water and try to be invisible. And according to The Hunt for Red October, try to make themselves sound like whales in the wilderness. But in reality, that's not what's happening. And when submarines are operating sort of near shore, there's all kinds of noise sources out there. Well, obviously, we're going to put several thousand wind turbines off the shorelines and create noise in the water. So now there's a questions popped up, and you see articles once in a while discussing, well, what are the submarines going to do? The turbines aren't that far apart. They're in a place around ports, kind of general vicinity of ports where submarines operate at. Is there going to be a lot of noise coming from the wind turbines such that the submarines may have a difficult time navigating inside of there? And it's gotten to the point where the Germans have been very proactive about it. And they have a system in Germany where the submarine pings via sonar, pings the turbines and turns on transponders. So all the wind turbines start talking back and saying, here I am, here I am, here I am via a transponder, so that the submarine crews can pick out where these wind turbines are in the water. It seems like in the United States, we really haven't discussed this much at all, but a lot of these wind turbines are around ship ports, and particularly where like Newport News and places where submarines will operate out of. Are they going to have similar systems in the United States or in other places of the world so that, in theory, a submarine doesn't run into a wind turbine?
To me, so knowing what advanced technology is available to the general public, usually we know that the military is 10 steps ahead of that, right? Like the military had centimeter accurate GPS for 20 years before the civilians did, right?
Yeah.
So, and again, knowing what's out there, I can, we were talking offline, I said, I can find a submarine in 60 meters of water with my fishing sonar. And you could see, I have this, here, modern sonar for survey operations can find this bottle of Topo Chico on the bottom of the seafloor. If the sonar in a whatever class submarine that you want to say is operated by any military in the world can't pick out I don't know exactly how big the foundation would be, but a 5 to 10 meter wide base foundation of a wind turbine offshore, I think we've got some bigger problems. Now, so diving into the problem a little bit, we know you're going to create wave noise. You're going to create scour noise. You're going to have some. Yes. You're going to have some subsea vortex-induced vibration, which will create some bad acoustics. Right. Those things are all true. Blades whirring around up top, that vibration going through the tower, that will emit subsea as well. While a subsea that acts as an insulator, there's a lot of noise in the water, which we can completely understand by basic physics. Also, you have some, the high voltage lines in the water. You're introducing some things like if you go North Sea and you look at the North Sea, traditionally it's a fairly sandy kind of silty bottom, but now you have rock dumps everywhere, and rock dumps create scour, creates subsea currents. These kind of things will mess with.
Right. True.
Right. So there is a lot more noise, and if you're trying to be in non-wartime safe, the really easy way would be put some kind of transponders on these things that are ping them. Now, another thing in shallow water, now GPS doesn't penetrate water, right? That doesn't work.
Right.
But these submarines have ways of locating themselves subsea.
Yes.
Very well. And all it takes is a screen with the GPS coordinates of the turbines on them to avoid them. So it almost seems like, hey, it's a government saying that we're going to do something here to alleviate everybody's concern that we might hit one of these with a submarine, but I don't really think it's needed. I mean, the other side.
Do you think it's well? Do you think it's for the Russians to avoid Russian submarines from running into German wind turbines? Do you wonder that?
Well,
could the Russians are running around, and the Americans are too, by the way.
Yeah, everybody is.
Not just one side.
Yeah, the Baltic Sea. The Baltic Sea is busy.
Yes, right now, very busy place.
But so, like in what we're reading bullet points from the press release, it says that the transponders are designed to be activated by a sonar transmission from a German submarine. So if they're only activated by German submarines, what's the point, anyways? They should know where their infrastructure is.
You would think so.
I mean, the other side of it is
well,
like a wind farm isn't that big. They might be a couple kilometers wide. Just avoid them. Like there's You don't need to go in there.
Right.
It's like when they're talking about fishing, commercial fishing and stuff, like they don't take up that much space. Just don't fish by them.
Well, is it a place for a submarine to hide?
Maybe that's you definitely got a point there.
Yeah, if you want to be in a place where there's enough noise where it'd be hard for to detect you. That may be
break spot.
A good place to go hang around.
Yeah.
Right. Well, and if the complexities add up quickly because as soon as we start dropping mooring chains on the floating wind turbines, that's a different thing than a fixed bottom turbine. So do you clip a chain, a mooring chain? Oh my gosh, I would hate to think about that. How much damage that would do. Yeah. Well, have we had submarines run into one another recently, or have a submarine accident in the U.S.? I think recently we did. And I think we recently had ships run near one another. So the chances of
it's possible.
Weirdly enough, I think it's possible just because of the odds, right?
Well, and if you look at
it's a busy operating environment, a lot going on.
If you look at the areas where offshore floating wind, now we're talking about mooring chains, right? So if you're looking at where they're installed, a lot of those are heavy submarine traffic corridors, right? I would think that they are. Yes. Offshore Norway, there's that shelf right there. I would imagine if I was a submarine operator, I'd be cruising right along the bottom of that shelf, sneaking by, So I don't. Again. I'm not a submarine. I've never been on a submarine. I don't know anything about how that works or submarine warfare. I'm not an expert, but yeah, I mean, so in the oil and gas world, you have a lot of moored drilling rigs, moored drilling or floating production storage, offloading facilities all over the world in the Gulf of Mexico, Africa, North Sea, everywhere. They're everywhere. And not only are there mooring chains going down, but there's production lines going down. There's production lines that are going down through kilometers of water that are carrying hydrocarbons from the seafloor to the surface. You clip one of those, now we've got a problem, right? So there's sonar targets that are hung from these things or attached to these things on the flexible risers and on the mooring chains quite regularly, and even on subsea infrastructure. Because if you've never seen it, something cool to Google is just like subsea oil field, just to see what the infrastructure looks like. It's just it like literally built. Build looks like it looks just like if you drive through Midland, Texas, and you see what the topside looks like. That's what it looks like, but at 2,000 meters depth water. It's pretty wild. But they have sonar targets all over those fields, so that when an ROV goes down there, because visibility, of course, is limited, boom. They pick it up and it just glows on the sonar, like the certain angles and stuff.
There you go.
So I would imagine we have some of those same things going on all of the mooring chains and whatnot. I don't know if they've.
So do you think your risk is? Well, do you think the risk is coming from the U.S. Navy, which seems to be a very competent organization from all my dealings with them? They really have their act together. Or is it coming from the submarines from like the Pablo Escobars of the world, where they're trying to bring in cocaine into Florida, that we have to worry about them running into some mooring chains? Yeah. So that's probably the more likely situation, because they have had submarines made to bring coke into America. Oh, yeah. That's the one that's going to get you. Right? Yeah. That's the one that's going to clearly smack a mooring line at some point. Then we'll really know what's going on in the waters when that happens.
It's scary.
Is that who it's really for?
Yeah, it's got to be. It's hard to like. So there was a picture or a video clip, maybe 6 months ago or something, of a vessel that had a DP runoff. And if you know what DP systems are the dynamic positioning, where you have multiple GPSs or ways of positioning a vessel, and it stays in one spot by itself, basically robotically through algorithms. And you can have a DP runoff where the GPS will get jammed or get lost, or it used to happen, doesn't really happen anymore, where the vessel will start to just move, where it thinks it's actually staying still. Mm-hmm. But it can also be where just like a part of the system fails, right? Like the bow thruster fails and the thing just starts going, like it thinks it's putting input in, but it's not. And one of them smashed into a transition piece. It was like 6 months ago or so. I saw a video of it. Where a vessel was just like bam into the transition piece and it messed the vessel up bad. And the transition piece had like a bent ladder on it. It was impressive. I was like, because I was thinking to myself, like, man, do they have to do a whole, like from an impact from a vessel do they have to do a whole engineering study? Are they going to have to look down to the seafloor, see anything move? And after watching the video, it's like, huh, it didn't look like anything really happened to it. So maybe a submarine will just bounce off. I don't know.
Just a couple of rattle cans of yellow paint. It's good as new.
Yeah, exactly. Maybe there'll be a submarine out there with one fin left or something. Can't turn left.
Yeah. Oh, man. Well, this again, we see some of these issues rise up as we get closer and closer to more wind timbers being in the water, where there's just a lot more discussions about what if, and I'm not sure I've seen many of these answered yet. I have a feeling that the Navy's figured it out. They just haven't told everybody yet. But I'm not, so like I said, I'm not worried about the U.S. Navy too much as I am about everybody else that's operating in those waters. And who knows, we may learn some interesting things about what's floating underneath the shoreline. So cool stuff. Well, Joel, if you follow the SEC filings, you will have noticed that Aerones has been in a Series A fundraising round, and they've locked in about $39 million of funding. It still looks like that Series A has about $2 million of space. So if you have a briefcase full of cash, you can send it to Latvia, and they would be glad to see it, in a piece of Aerones. But they're fundraising because they're expanding very quickly, and I think this is a good sign for them. It's hard being in that business. It's just a cash-intensive business. It's not a software company. It's a hardware company, and they need to keep fundraising to stabilize it and get it to the point where it's just a global powerhouse, don't you think?
Yeah, I mean, they do a really good job over at Aerones of getting out and getting some reach out in the world, right? You see them in a lot of South American countries. Every trade show on this side of the pond in the U.S., we see them at every trade show on that side of the pond. In the EU, we see them at. So they're spending a lot of money getting the word out and stuff. But the capital-intensive part of it, when you talk about software company versus a hardware company is also a software company, especially when you're talking robotics.
It is,
right?
Yeah.
So those guys are the amount of capital that goes into building something like that. It's intensive, and then also think about what the business model is. The business model is getting robots mobilized around the world and out onto wind farms, paying a couple, 3, 4 people to be out there doing these things. All the training that goes along with it, like it is a very capital intensive business model to get off the ground and get running, but could pay off, right? As we talked about earlier in the episode with the shortage of trained technicians in the wind industry that were completely up against the wall, keep just pounding and pounding and pounding. We need more. They may have a scalable solution here that can fix that problem, and if they can do that, 39 million in funding could become 39 million in revenue real quick.
Oh, I hope so. I really do. All these robot companies the people working at these companies are working their tails off. Every trade show I see, every report I get back about where they are in the world indicates they are really trying to make a difference out there, and they're only a small percentage of the total repair market as it sits today, but hopefully they can become a much bigger dominant player, because we're going to need it.
Yeah.
Without them, we're never going to achieve some of these goals in terms of gigawatts installed. It just won't happen.
Yeah, I know that Aerones is working, because we were kind of talking about this offline. They've got some LEP stuff they can do. They can do lightning protection system testing, drain hole clean out, tower cleaning. And I believe they're working on a system that can do some at least light repairs. I know Rope Robotics is doing the same thing. They're a part of a consortium group that has some funding is going to come out to do some hopefully do some actual repairs. And when we get to that level, well, that's a game changer there as well, right? Because then you become more than just a leading edge protection tool, and you become a technician but with the robot instead.
Right. Well, and because this is a Series A round, that's like the start line, right? Weirdly enough, in investment world, You get to Series A, that's the gun goes off. You start running from there. You're trying to get to B, C, and D if you need it to have a self-sustaining company. Now the real race begins. I think it's hard to process all that, how hard they have worked to get to this point. And now it must in some way feel like, okay, I have this new lease on life.
Yeah.
I have all the robot thing kind of figured out. I have technicians trained. I have robots in different countries already stationed to go. Now it's really go time.
Yeah.
Like the last 3 years haven't been go time compared to the next 3 years. Wow.
Yeah. Wow. It's going to be crazy. It'll be a fun ride to be a part of. I know next time I see Dennis Cruz, I'm going to ask him how he got away with calling this is round A, but
yeah. Yeah, I understand what they're trying to do. Everybody's playing that same game, but there hasn't been the only other company I can think of that has that kind of Series A that's really in the business is SkySpecs, right? Yeah. That SkySpecs has been fundraising, and it's good to see Aerones in that same space.
Yeah, I look to see big things from them. I mean, of course, if you've been to any kind of industry events in the last few years, you've seen Aerones. You've seen the team, you've seen the BD people, you've seen the CEO, you've seen everybody there. Yeah, I would say pretty soon you might see a bigger booth and a fancier booth from the Aerones team.
You will. Well, with 39 million, I hope so. Yeah. That's good. That's the way it should be.
Yep.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
Welcome to the program, Henrik Stamer. Glad to have you on the podcast.
Thank you for having me here, Alan. I'm happy to be here.
Henrik is the founding partner and managing director of Naver Energy, which is based in Denmark. And Naver Energy is a relatively new company and focuses on management and advisory services for offshore wind projects. So we thought it'd be great to have Henrik on the podcast because we just had the California offshore auction. We just got through the New York auction, and there's auctions going on around the world, actually. And we at Uptime don't know a lot about offshore wind here in America, so we thought we'd bring in an expert. So Henrik, welcome to the program.
Thanks again. Yeah, you guys are really hitting off with some very interesting visions for offshore wind, both on the East Coast, of course, for many years, but now also on the West Coast. So it's very exciting.
It is exciting, and just having finished the California offshore auction, there's a lot of questions about that. And if you look at the press and read the news articles, obviously there are 5 different companies, and some of them were conglomerates, so there's more companies involved. But they tended to be companies that have some expertise, mostly in onshore wind, a little bit of offshore. Equinor is in there. But in America, there's so many unknowns, and I'm really glad to have you on the program. Just because I wanted to talk through something we have been talking about on Uptime for a while, which is supply chain, and how difficult it seems at the moment to acquire turbines, to make contracts, to figure out what turbine you're going to use. And it seems like to us at Uptime that the OEMs are being very choosy as to who they will work with. Is that what's happening behind the scenes?
Very much so, Alan. What we see as well is that the OEMs, they have sort of a bandwidth, and they would like to use their sales time with the most the developers that are progressing the most, and seems as if they have the right pipeline in place. So that means that whereas in the past, just a few years ago, the developers, they were very certain that they could get in contact with the turbine manufacturers and participate in a good conversation around their specific project. But nowadays, things has really changed.
Well, I'll use the California auction as another good example. There were 43 companies that had been authorized to bid in that auction. I think at the beginning there were 7 or 8 that started, and there were 5 at the end. So the vast majority of companies that had applied and were registered to bid on those leases didn't bid. My guess at the time was that they didn't have a contract with an OEM, or an OEM wouldn't talk to them in terms of securing wind turbines, and even same thing for cables and foundations. Is that what's happening? Is it early on the larger players are able to make those contracts because they have a supply chain?
Absolutely. I mean, it's not only the turbines, as you say, it's also the foundation suppliers and the cable suppliers. They have, I mean, over the past several years, they have been taking new products to the market. So that takes a lot of investments. At the same time, they have not been so profitable. So that means that they have certain amount of capacity, and again, they want to deploy that capacity in the future with the developers that they really believe in, can have, you know, be successful in winning auctions and have the right team and management, and of course cash to make these projects happen happening. Otherwise, you know, you spend your time as a wind turbine manufacturer or a foundation manufacturer in a wrong way. So it's really sellers market at the moment, and they are already now, what we see is that they are demanding some fees from the potential buyers to involve them in a sales process. So again, it could be, come back to your question, it could be one of the things that some of the already listed and listed bidders at the California auction, that they realize, well, it is difficult and this is going to be a very competitive bid. So if we cannot even engage the supply chain, then we might as well go back and revise our strategy and maybe go for something that is more long term, or in a more emerging market where you are not bidding and actually paying for the auctions that you win.
Right. Once you win an auction in the United States, you have to pay those fees up front. And the United States federal government and the state government would love to have you put wind turbines out there, but there's no guarantee that you will be able to do that. But the money is exchanged. And so you have to try to develop that. And it seems like it would be a big risk if you can't lock in at least one of the OEMs into a supply chain deal as to how many turbines, when you're going to put them out at sea. Those seems like a very big risk as a developer to get those contracts in place. And if you mentioned that they're asking for fees, I think that makes a lot of sense to me because they're cash hungry at the moment. Does that change if I'm a developer? How big of an impact is that on me, where there's a limited number of manufacturers, they have a tight supply chain at the moment? Does that really change the structure of the economics, the financing of a project because of that constraint at the moment?
I think it may change that a bit, but I think what is really the risk for a developer is that they end up having one, let's say 3, 5, 600 megawatts somewhere, pay for that, but because they lack a bigger pipeline of offshore wind projects that is secured, then they really cannot get the turbines and the foundations for that specific project. We've seen already now that if you have less than 1 gigawatt of pipeline secured, you are really not a company that are sought for or sought after by the salespeople the turbine manufacturers and foundation manufacturers. So what you want to achieve is to establish a pipeline of a certain size, so at least more than 1 gigawatt. That could be in different locations, of course, but that's what we are looking at the moment. Less than 1 gigawatt, you are sometimes, if you're taken seriously, you're sometimes put aside to a special project, a kind of sales organization where there's a limited amount of support. And we all know that buying turbines is a complicated matter because you need to factor in all the local content, both in terms of technical specification and also local content in terms of compliance with all sorts of regulations. So it's not something that you just buy off the shelf. It really needs to have you need to have some traction with the OEMs in order to establish the right setup for that specific turbine that you are acquiring.
Well, that makes sense because some of the California auction winners were actually a combination of two larger energy players, two or three. And is that the reason why? Is because between the two of them, they can show a pipeline of 1 gigawatt plus projects? Is that the logic behind it?
It is the logic behind it, and also because there's a very big push towards many of the players at the developer side or the investor side to be able to deploy their funds into renewable energy. And I think the philosophy is if you cannot beat them, then join them. So better form these partnerships so that eventually you will win just a little bit and deploy just a little bit of your funds instead of losing out of opportunities elsewhere. And it's also better to be part of something that is a success with 25% instead of standing outside, because when you are involved, you also get some experience out of each and every project that you can then utilize in the month and years to come, and revise your strategy and become even more competitive in the future.
I noticed that in the auction that the people that or the companies that were bidding were companies that had expertise, or if they didn't have direct expertise, they were trying to grab hold of expertise, and that's where Naver Energy comes in, right? Because it is such a complicated projects to develop. You need to have steady hands on the controls to help minimize those extra costs and those complexities that you haven't thought of before, especially if you're new to offshore wind. And Naver is a relatively new company in the space. How do people get a hold of you and to your expertise? How do they reach Naver Energy?
Yeah, so obviously we make ourselves available everywhere, on the internet, but we are also we are part of a wider group of companies that are focused 100% on offshore wind. We are part of Ventera Group, that are currently more than 450 employees deployed over 8 different companies, and one of them is actually a US-based company, Inspire Environmental, down in Rhode Island, and we have recently opened up a Ventera Group office in Rhode Island in Providence. So for US clients, we have a presence, and we are operating out of that legal entity, and we can service in US. We are born out of Denmark, and as everyone knows, that's where everything started. Of course, there's a lot of competences in many of the other European countries, like just south of us in Germany, where we also have a group presence, in UK and Ireland, where we also have presence, and then we are also expanding to Asia. We have already entities in Taiwan and in Australia as we speak. But the idea is actually to bring a lot of the European knowledge that are common for every single offshore project, and which can then be reused in a US context. And then, of course, we will like to form strong partnerships with local companies in US in order to also complement our knowledge and know-how from Europe with what is local requirements and local compliance with local legislation in order to be able to support developers in both the East Coast and West Coast in the future.
So if you're planning on an offshore wind project, or maybe you just won an offshore lease off the coast of California, reach out to Henrik and the Naver Energy Group. Henrik, it's great to have you on the program, and we'll have you back soon.
Thank you very much. Thanks for having me.
That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Please take a moment and give us a 5-star rating on your podcast platform. And be sure to subscribe in the show notes below to Uptime Tech News, our weekly newsletter, as well as Rosemary's YouTube channel, Engineering with Rosie. And we'll see you here next week on the Uptime Wind Energy Podcast.